we were talking of mechanical properties that are improved, right? So in hot working, as I was just saying, you heat it to a high temperature and then you bring the temperature down. So in your material science course of phase diagrams and so on, you remember that by controlling the rate of cooling, you can control the grain size formation. If you produce a small grain size, you remember Hall-Petch equation and a small grain size. That small grain size means lots of grain boundaries, and that means a material of higher strength, right? And a small grain size means the material properties are very uniform throughout. So the strength, and of course that means hardness and toughness and so on, are all improved if you make the grain size small. And you can control the grain size by controlling the rate of cooling when you come from a higher temperature to lower temperature. So because in hot working, that is automatically happening. You have a metal, but now you are increasing the temperature of the metal, working it, and then bringing the temperature down. So the grain size changes, and as soon as the crystal structure changes, the grain size changes, material properties can be improved, right? So this way material properties can be improved in hot working, right? So you see, this is just one slide, but some of the points you could automatically tell us that what it is. It requires a lot of cost, it includes big equipment, the heat handling problem is large, and so on, and then these are the advantages and so forth. So I totally disagree with a general statement like this. It is from the book, but mechanical properties are improved, yes or no? Yes and no. Yes and no. Some mechanical properties will be improved, some mechanical properties will go down, some will improve like this because of this scientific reason, some will improve like this because of some other scientific reason, some will go down because of this scientific reason. So it is, right? So mechanical properties are improved in hot working because of one thing, in cold working because of something else, right? So this is it, that many times in engineering and science, the answer is not definite yes, not definite no, but conditional answer. Cold working, again, stop the slide. Think of all of the points that you just did on the previous slide about hot working. All of the points about hot working. And now think that same points. How do you answer same points in terms of cold working? How do you define cold working? What about the equipment and tools in cold working? What about the temperatures in cold working? What about the mechanical properties in cold working? What about brittle materials in cold working? What about surface finish in cold working? Right? So each point that you discussed on the last page, now you think in terms of cold working. So stop my video, pause it, think yourself. You see, I keep on requesting you to do that. If you do that, you are a far stronger engineer than many others because you are thinking. There is a thinking machine up there. But of course, it is totally your choice. You said, no, I will just listen to your lecture and that's it. But just listening, I mean, you see, it is a very bad example, but a very true one. You go to Jummah prayers, right? Nowadays, no, but Jummah prayers. And for 20 minutes, 30 minutes, the Imam is talking to you. There is a khutbah and it's very important. A lot of Quran is there, a lot of Hadith is there and so on. Half an hour after that, if somebody asks you what was there in the khutbah, maybe you can't even remember 10%, 20%. Very rare people will remember most of it. So when you are completely on the listening side, you are not interacting at all, you are not thinking at all, then even the most brilliant lecture goes away. So if you just listen to me, then after some time it is gone. But if you interact, you stop, you think yourself, you take some points, you make some notes, you debate yourself, then come back, so if you keep on doing that interactive, then it will be there in your mind for life, right? Okay. So after your pause, now you are listening back to me. Cold working is carried out below recrystallization temperature, of course. Hardening remains in material after cold working, right? So now it is cold working, so strain hardening will be there. Strain hardening will be there. High force is required for deformation as material is less plastic, of course, right? In hot working, the material had become softer, so you needed less force and therefore lighter equipment. Here, high force is required, so heavy and more powerful equipment is required. Here they are saying no such difficulty in cold working. So you have to go back and remind yourself that what was the difficulty. So let us go here. Surface finish is good. So this I have explained to you a lot. In cold working, surface finish has problems because of high frictional forces. So you have to design the force that you will apply and the rate at which you will apply so that the surface is good. But scaling and chemical reactions do not happen. So surface finish here is safe from scaling and chemical reactions that happen because of hot working in the previous one. Cracks and pores are developed. No, can be developed. Are developed is so bad. Are developed means whenever we do cold working, they are always there. So if cracks and pores are there, then my goodness, what are you manufacturing? Every product is defective. No, so cracks and pores can be developed. If you do not control the force that you will apply and the speed at which you will apply it, then on the surface there can be cracks and pores and so on, right? But otherwise, in cold working, you control everything properly. The die is made of a very good material. The surface finish and so on is good. The forces and speeds are under control. Then the surface will still be good. Otherwise, if it always happens, it says are developed. If it always happens, then we should never do cold working. Okay. Mechanical properties are adversely affected. Adversely means bad. Mechanical properties go down. I told you, I have discussed this very much, that no, this is not true. In cold working, strain hardening is already happening. So strength and hardness are improved, right? But ductility goes down and some other problems may happen. So with mechanical properties in hot working, in cold working, there is no yes, there is no no. Some are improved, some go down. And of course, this is very clear that brittle materials cannot be cold worked. Brittle materials cannot be cold worked because brittle material is brittle. It goes to the yield point and suddenly breaks. It does not go through deformation. And if it does not deform, there is no manufacturing. Manufacturing means deform into the shape of the design, right? So in cold working, you apply load, apply load, apply load, and suddenly the material will break if it is brittle. In hot working, the brittle material does not remain brittle anymore. It becomes a ductile material because of heat, right? So this point, that what was the point here? No such difficulty in cold working. Remember, handling due to high temperatures. Handling due to high temperatures is a major issue. You see, you have something at 300 Celsius and the weight of that something is 10 kilogram. How to handle it, how to do this, be very careful. Here it is all room temperature. So that is not an issue, right? So we have not gone into any specific extrusion, forging and so on methods. But in general, we are talking of bulk deformation. And just these two slides of major points in hot working and major points in cold working should really open your mind. Really open your mind that, you see, it is not that unless we have an equation and we have a problem to solve, we are doing engineering. No, just by discussing and thinking, and most of the times 40%, 50%, 60% of the answers are there if you think based on your earlier knowledge, right? So this, I hope that these two slides, they took a lot of time, but they were worth it. One of those very good pages which I keep on telling you that every figure is good, every slide is good, but some are extra good, right? So process, forging flat rolling, shape rolling, extrusion, drawing, swaging. These are the different bulk deformation processes that will be later described in the chapter, but general characteristics of each one of them. So this is brilliant. This is brilliant. If you print it and keep it in front of you, then for the whole bulk deformation chapter, if you understand it, then with this one-page summary, you can tell all the different operations of forging and rolling and extrusion and so on, and their major points. So please spend some time on it. I will go through only one. For example, forging. Production of discrete parts. Discrete means separate parts. You see, why are we saying that? Because in extrusion, production of long lengths. So there is a certain shape and I am making 20 meters of it in one go and then cutting it into 1 meter, 1 meter, 1 meter. So after cutting it into 1 meter, 1 meter, 1 meter, I get discrete parts. But in forging, I press into a die and then I take the upper part away and take out the part. So I produce one part at one time, not a continuous part. So therefore, production of discrete parts with a set of dies, at least two, an upper die and a lower die. Upper die is many times called a punch and a lower die together, right? Some finishing operations usually are necessary, that even after doing forging, it is not the final complete shape. Sometimes we need some finishing operations. Similar parts can be made by casting. The parts that you are making by forging can also be made by casting. They can also be made by powder metallurgy. So it depends on your cost and quality and time and a lot of other things, that whether you will make the same part by forging or by casting or by powder metallurgy. Forging is usually performed at higher temperatures. Usually cold forging can be done, but mostly it is hot forging. Dies and equipment costs are high because we hammer the material into the lower die, impact load. So we need a press which can apply a lot of force with a lot of speed, and the die and so on have to be very high quality, otherwise they will fail. Moderate to high labor costs. Labor costs are moderate to high, not very low. And moderate to high operator skill. Operators are not very unskilled, but moderate to high. So you see, these are the points, that what is it? What are the advantages, disadvantages? What are the limitations? What are the costs and this? So this you study about all of them, about each one of them, general characteristics of bulk deformation process. And just by having this one page, now if you give a seminar somewhere, a presentation somewhere, then just by this one page, you can describe the whole chapter in a nutshell, right? So please go through each of these: rolling, extrusion, drawing on this page, and then and again, right, do it once, understand it, some later time, 1, 2, 3 days later, do it again, because until you repeat it a couple of times and you think about it each time, you are not really doing it, right? I am not asking you to memorize. I absolutely dislike this word of memorization. But yes, things are in your memory because you were thinking, right? So that is the thing, that you are not doing memorization by memorization. You are doing memorization by working, memorization by thinking, right? And so on. So please do that, right?